Hi, my name is Michael Baisa. I am going to be presenting today on Java and JUnit. So, a quick introduction to JUnit. JUnit is a Java framework library that is specifically designed for program testing. Now, with the software development, there are different levels of testing. This one particularly focuses on unit testing. So, taking small segments of code, your methods, and running them through particular tests to make sure that they're working as they're expected. Now with JUnit 5 is the most recent version of JUnit to come out. I ended up finding more documentation on JUnit 4 and decided that with being able to more easily implement it in IntelliJ, I went ahead and implemented JUnit 4 in the program that I put together. And that one's also been well documented, so I feel pretty confident with it in going through it. In implementing JUnit into your testing for your programs, there are a few steps that you want to take, of course. You're going to need to download the actual library or include it if you're using an IDE that allows you to more easily include libraries. And then you're going to create the class or classes that are going to be tested. So this is going to be what is it that we're trying to make sure works properly. Once that's done, then you'll create a test class, and these are denoted by a test annotation for all of the items that you want to test, as well as assertions which are included in the test class to represent whether or not something is working as expected, to test to make sure that those are working properly. Now, if you are testing multiple classes, you can create a primer file which allows you to test multiple classes simultaneously. And once you've set that up and once you've set up your main function, you can go ahead and run those tests and then capture and review those results. Now with JUnit, you have a number of assertions, and assertions are the ones that allow you to test to make sure whether or not something meets a certain criteria. So taking from the requirements for basic, I listed all of the assertions that are included here as key assertions that you should be familiar with. The first one is assert array equals, and this will take two arrays and test to see whether those two arrays are the same. The second one is assert equals, and this will take either a primitive or an object on both sides of the parameters and test to see if those are the same. You have an assert true, which takes a boolean, and if it returns true, then that passes the test. Assert false, if it returns false, passes the test. And then of course, null not null, test to see whether an object is null. And then assert same, not same. This one is in particular testing whether or not an object, whether or not two references to an object point to the very same object. So with that, let's go ahead and go through a demonstration of JUnit. So this is the program that I put together, very simple. I put together a couple of classes to test, balance sheet and income statement. I ended up deciding that we'd just stick with balance sheet. That would be enough for our purposes. So this is the class that I want to do my tests on, make sure things are working properly. So this contains very minimal information, a string, a few floats of financial information, and then a list of transactions. So this is the class that I'm going to be testing in my test class. And then right over here, this is the actual test class where we're performing various tests, making sure certain things work out properly. Now, given that this is thrown together as an example, this isn't necessarily going to be practical for a particular program. But I put together 4 different methods which take together the various assertions. This first one tests not null, null, same, and not same. So as we're going through here, we'll see that assert not null, we're testing this to make sure that this particular object is not null. We're taking, with this assert not same, we're taking these two objects here and making sure that they are not the same. In this case, I took one instance of a balance sheet and one instance of an income statement, which are two completely different objects, and those should not be the same. So that's the assertion there. We have an assert null here, so I created a new instance of a balance sheet that's set to null. So here we're testing to see whether it's null, and then assert not the same. So since this is a newly created balance sheet, these two balance sheets should not be the same, and that should assert to true. And then I take this sheet that we created, and then I assign it to be the same as test balance sheet. So then I run the assert same, and at this point, those two should be the same object, or references to the same object. The next method tests the assert equals, and in here I've got two instances of assert equals. This one takes an object, so this will take the float version of a particular object and test if they're the same. And then this one takes a primitive version, so it takes two primitives, which in this case are floats, and tests to make sure they're the same. One interesting that I did note in working with floats on this particular one, for assert equals, if you're working with primitive floats, you need to include a delta, which is basically how much error are you going to accept with the floats. And in this case I said if it's within 1 cent, then it's fine. Let me go ahead and delete this here because this will be part of my example later. With this third method, we're working on testing array equals. So I create a very simple float, a float array, and then within the balance sheet, I include a transaction which also creates an array list, which I then translate into array for purposes of testing the arrays. So with these two arrays, I run assert array equals, and again dealing with, so we'll take the two arrays that I created, and since we're dealing with floats, we've also got to include a delta, and it tests those two arrays to make sure that they're the same. And the last method that I included as part of my testing includes testing for assert true, assert false, and assert that. So my assert true here, in taking a look at this, in accounting, the basic formula that you have to remember is assets equals liabilities plus equity. So we're taking a balance sheet that's been created and we're saying assets equals liabilities plus equity and assert whether or not that's true. And with that, that should come out to be true. Then I run a transaction, and to test assert false, we say if with current equity, okay, so we captured current equity earlier before the transaction, and then we take a look at is current equity the same as what happens after the transaction, and we expect it to be false, which I won't go into the details for that. So that's the test for assert false. And then I also run the same test using assert that. This happens to be the same as the assert false test. One thing that I did note in taking a look through the documentation is that assert that is a deprecated method, so it's not something that's encouraged to be used, although it is still something that is available within the JUnit library. So those are the tests. And I put together a test primer, which I didn't have to do because I've only got one test class that I'm running, but this is how you would more or less do it. You would define a run with a suite class, and then with the suite class, you have a comma separated list of all the classes that you want to include as part of your tests. In this case, I've only got one to test, so I just have that one item listed here. And lastly, I set up the main function which runs the actual tests. I use a JUnit core and then run classes linked to the test primer that I created, and with that I'm able to retrieve the results of the tests that I'm doing. And then if there's any failures, I'll go ahead and print out those messages. If everything was successful, then I'll just print a congratulations, everything passed message. So with that, let's go ahead and take a look at this program run. So I'll let this build for a second. And you'll see that as I've set the program up, all of the assertions are true. They're all doing exactly what we expect them to do. So go all the way to the bottom here. All assertions are true. Now let's go ahead and take a look at what happens if I break one of these assertions. So go to our balance sheet test. And for ease, let's go ahead and take this, this assertion right here. Your assets should be the same as your liabilities plus your equity. But let's go ahead and break that by adding 1 to the other side of the equation. So if we run this again, let this build for a second, you'll see that a number of the other units tested properly, but then this particular one failed. Expected 275, but was 276, and that's what happened here. Is we added 1 to the other side of the to the second parameter on assert equals, so we're not matching there. And with that, I'm able to display the message for this particular one, and also display a trace, which allows me to more quickly find where that error comes from. So, and you can do this with a number of the other tests too, where it will show you what the issue is. Let's take another one really quick, just for example. I'm going to correct this one first, so put this back in balance. Now, let's go over here, and instead of this being assert null, let's assert not null. So this one will fail. And we see that the message is test was null, and then it shows us where this is, and we see that this was supposed to be not null, but in this case it ended up being null. Let's do this for this one right here. We'll change not same to same. Go ahead and run this one more time. And of course it fails. And we see that expected same. And this gives a memory reference over here with the two not being the same. And we can easily find where that is. So with that, I hope that gives you a good introduction to JUnit and what it can do to help improve your testing, help you to have the resources to make sure that your classes are prepared properly and make your programs more efficient, more effective, and hopefully developed faster and more accurate as they should be. We'll look forward to hearing any responses that you have to this, and look forward to continuing to work on Java. All right, have a good day.